Hello everyone, my name is Rintu. I am a master's student in the Department of Biological and Agricultural Engineering at Kansas State University. Today I am going to present my research, and my research topic is impact of climate change on suitability of major crops in eastern Kansas River Basin. We know that agriculture is highly dependent on the climate. Extreme climate change could significantly impact crop yields. So it is essential to find future potential and vulnerable crop growing areas on a regional scale to choose the right crops over time and provide adequate adaptive measures for that location. The map is showing my study location. It's known as Eastern Kansas River Basin. It consists of total 17 counties. My study location has the favorable climate for growing crops under rain-fed condition. But Eastern Kansas is vulnerable due to climate change. So the objective of my research work is to assess the impact of climate change on crop suitability in Eastern Kansas River Basin. In methodology, I am going to introduce a process-based crop model known as Decision Support System for Agrotechnology Transfer, or the DSET model. And the model has been using as a tool to assess the impact of climate change in crop production studies. For this study, for historical climate data, I have used GridMate data source for 1990 to 2019. For future climate, I have used 18 downscale global circulation model from 2006 to 2099. And I used representative concentration pathway RCP 4.5 and RCP 8.5. For soil, I use Soil Survey Geographic Database. And for run that DSET model, I used weather, soil crop management, and genetic coefficients as the input data, and the model simulated or projected actual and potential yields as outputs. And finally, I used the yield gap percentage formula to calculate the suitability in my region, and I use national average yield gap percentage to divide my study area into 3 groups, that is suitable, moderately suitable, and unsuitable. And finally, I use the ArcMap 10.8 to map the suitability in my region. The box plot here is showing the regional average yield variability under present and future climate change scenarios. We divided our study period into 3 groups, that is near, mid, and end centuries, because we are comparing the yield variation with the baseline study period. So here we can see the yield loss is highest at the end of the century under RCP 8.5 for both groups. For maize, it's up to 59%, and for soybean, it up to 48%. Only soybean increased 6% in the near century under RCP 4.5. So more precisely, if we want to know about the future yield gap, the figure is showing the yield gap percentage trend, and under RCP 4.5 for maize, the yield gap is 38%, but under RCP 8.5, it's the 52%. For soybean, under RCP 8.5, it's 38%. So here we can see the maize suitability map, and here green color represents the highly suitable areas, yellow color for moderately suitable, and red color for unsuitable. So under future climate change scenarios, the maize suitable area reduced from 98% to 50%, and under future climate scenarios, for soybean, the soybean suitable areas reduced from 94% to 73%. So from the above discussion, I want to conclude that under RCP 4.5 and 8.5, the highest yield gap was recorded for maize. The projected suitability of maize and soybean shifted due to the climate change. In my study region, under future climate, soybean production and suitable growing areas are increased over time. So we can say soybean is a robust crop under future climate change condition and can be a good choice under extreme climate change situations. Thank you for your attention.